E9. And our 10 dynamics problems, we're up to 9. And this is the conical pendulum. Now for a conical pendulum, you have something hanging here like from the ceiling, some angle theta, and this thing's going around, so a horizontal circle. So say some distance r away, some mass m, and this some L, and some tension in the pendulum. So, you know, here's the situation. You got a right angle here, and that's our sketch. And the question is to find the angle theta in terms of the other parameters. And usually in these problems, they probably will go ahead and tell you little m, v, r, g, although one of these may not be relevant. But they should tell you that because, you know, there's this capital L, and there's also, you might say, the height h there. So, and there's this angle is made with respect to the top. So this angle here is complementary, and we'll use that. So for the force diagram, we have mg going down, and we have some slant for the tension T, and this here is going to be the angle phi. So for the equations, main equation here, let's see, if we go with the sum of the forces in the x direction, let's say this is x and y, then that's going to give you F equals ma, since that's going to be acceleration regarding with the circular motion. So that would be here, giving you the tension T with the cosine of phi is mv squared over r. Then the sum of the forces in the y direction, that's going to balance. There's going to be no acceleration there. So that's going to get you T sine of phi minus mg equals 0. But since the phi and the angle theta are complementary to give you 90, then we can write these equations, cosine becomes the sine of the theta. And here, the sine of phi becomes the cosine of theta. And here I'm going to divide the equations. So here, so now when you're doing homework problems, you don't really need to put these steps down. This is just for us. These steps are for us so that we know we have a prescription, we have something that we do in solving problems. But you need not put those steps down. Specifically label those like when you're doing homework. Always listen to your teacher when you're doing homework problems. Keep your teacher happy, whatever they want. It doesn't hurt to put these down. It helps to organize it. So if you want, sure, go ahead and put those down. And now solve the equations. So we're going to divide, and we're going to get tangent of theta is mv squared over r divided by the mg. And the m's cancel, and I get v squared over gr. And that is the formula. So we could say the tangent of theta is v squared over gr. You know, you might want to technically have the angle by itself, take the inverse tangent, since technically this would be the way to show the angle by itself on one side of the equation. All right. Now there was a second part to this problem which has numbers, and that's this part here. Find a specific angle when the mass is 3.6 kilograms, 2.1 meters per second, and the radius is 1.2 meters. But before I do that, let me just show you that the M didn't matter. See, we have V, we have R, and we have G. M didn't matter. And now if we want to plug in to find with the numbers, it said that V is 2.1 meters per second, gave us that. It gave us R is 1.2 meters, and it gave the mass as 3.6 kilograms, but don't really need that if I'm going for the angle. So therefore, with these numbers in there and G being 9.8 meters per second squared, and this is worked out in more detail in the text that goes with this video, and that's 21 degrees for this specific case. That's the angle with respect to the vertical near the ceiling there. All right. And there was a third question here, and that is to find L in meters. Find the length of the pendulum. This is sometimes called the bob of a pendulum, that mass there. And it usually goes back and forth, a regular pendulum, but this is a conical pendulum, like trace it out like basically a cone. See? That's why it's called conical, because it's like a cone there. So, and you're going around in a sort of horizontal slice there for the circle. Okay, so that would be here. Probably simplest way to do that is that the little r is big L C times the sine of theta. So that means L is R over the sine of theta, and R is 1.2 meters. And then this is the sine of, now always round off last, so that 21 was before rounding off, 20.556. Again, you can refer to the notes. And that's equal to 3.418 meters. And now we're going to go with the two significant figures. Is more reasonable there and there. So we have the three answers. This was question 1, question 2, and question 3.